This is SprintPilot, a complete task dashboard built from one repository, split into 4 parallel coding workstreams, then merged and tested as one application. The interesting part is not 4 chat windows. The real question is whether parallel agents can produce compatible code that survives integration. We will build the database backend routes browser dashboard and test suite, then reproduce the workflow with isolated Git worktrees. I am not pretending this sandbox is a paid Codex Ultra session. The local lab reproduces the engineering workflow and records every result. OpenAI describes GPT-5.6 Ultra as its highest capability setting, coordinating 4 agents in parallel by default for demanding work. Codex supports workflows with several agents built in work trees. Let separate agents work on the same repository without touching one another's checkout. Parallel execution only helps when responsibilities are separated. If 2 agents rewrite the same file, speed quickly turns into merge conflict and review debt. SprintPilot is small but complete persistent tasks, 3 workflow states, priorities, live statistics, a responsive dashboard, validation, and tests. The project uses Python's standard library SQLite and a browser interface with JavaScript, so viewers can run the tutorial without installing a framework. Before any implementation, we define acceptance criteria, create tasks, persist them, change status, show statistics, reject bad input, delete tasks, and pass tests. The shared contract defines 1 task shape, 3 valid statuses, 3 priorities, and the routes every workstream must agree on before coding. Agents.md keeps the boundaries explicit, stay inside your scope, validate rights, keep the project reproducible, and treat tests as the merge gate. The companion project includes a Codex Ultra prompt that assigns 4 roles, defines file ownership, and requires a final test run after integration. The architecture agent owns contracts and acceptance criteria. It does not implement the server or interface, which keeps its changes small and reviewable. The backend agent owns SQLite persistence validation logic, and the local web server, its scope, stays inside the Python application files. The frontend agent owns the responsive dashboard, statistics cards, task lanes, create form status actions, and delete control inside the static directory. The quality agent owns service tests and local web route tests. It verifies failures to not only the happy path that makes a demo look good. Each role starts from the same base commit on its own Git branch and worktree, so every agent gets an isolated copy of the repository. A worktree gives each agent independent files while preserving one Git history that makes parallel work visible without constantly stashing or switching branches. Agent 1 adds the acceptance checklist persistence across restart, structured errors, browser, usability, status, transitions, deletion, statistics, and a complete passing suite. The backend creates a tasks table with an integer identifier, required title, constrained status, constrained priority, and automatic creation timestamp. The database layer implements list, create, status, update, delete, and statistics operations. Every operation opens a short transaction instead of sharing global state. The service layer rejects empty titles, oversized titles, unknown priorities, and invalid statuses before those values ever reach the database. The server exposes task and statistics routes, returns structured errors, limits request size, and serves browser files from a controlled static directory. Static file requests are resolved under one configured route, a path that escapes that directory is rejected instead of becoming an accidental file browser. The dashboard uses 4 statistic cards, a compact task composer, and 3 lanes for to-do, doing, and done work. The browser loads tasks and statistics together, renders each lane, then refreshes the full dashboard after creating, moving, or deleting a task. Task titles are escaped before entering generated markup. Even a tiny tutorial should avoid turning text from the user into executable browser content. Service tests cover default priority trimming, invalid titles, status changes, deletion, missing records newest items first and aggregate statistics. Integration tests start the local server on a temporary port, create tasks through the network, patch them, delete them, and verify error responses. Now we merge architecture, backend, frontend, and quality branches into the base repository. The Git graph preserves exactly where each workstream entered. The first complete run is not perfect, 21 tests pass, but one statistics test fails after the 4 branches are integrated. The failure exposes shared temporary database state between test cases. Individual code looked reasonable, but integration revealed hidden coupling. The correction gives each database kept in memory a unique identifier, preserving shared connections inside one case, without leaking state into the next case. After the integration fix, all 22 tests pass. That second result is the merge gate, not the fact that 4 agents finished their tasks. We seed 5 tasks across the 3 workflow states: 2 to do, 1 doing, and 2 done, giving the dashboard meaningful data immediately. Running app.py with the seed flag initializes SQLite and starts SprintPilot locally. No cloud service is required for the reproducible demo. A real request to the running application returns 5 total tasks with the expected 2, 1, and 2 status counts. The final interface shows the project summary status totals, task composer priority choices, and 3 clean lanes with actions on every card. When the user adds a task, the browser sends the validated title and priority, the server persists it, and the board refreshes from stored data. Starting or finishing a task changes only its status. The server validates that transition value before updating the matching database record. Deleting a task removes the record and refreshes both the lane contents and aggregate statistics, keeping the interface synchronized with persistence. Because tasks live in SQLite instead of browser memory, stopping and restarting the server preserves the project board without any extra infrastructure. To reproduce this workflow in Codex, open the repository, choose Ultra, and paste the included project prompt for 4 separate roles in this build. Keep the architecture, backend, frontend, and quality scopes. Separate shared contracts can be reviewed together, but implementation ownership should stay clear throughout. Allow each Codex thread to work in its own worktree, review diffs per agent before moving any branch toward the final integration state. An agent saying finished is not a release signal. Require tests, inspect the changed files, and confirm that branch ownership stayed within scope. The merge gate should include automated tests, a focused diff review, and a manual smoke test of the behavior users actually care about. Ultra intentionally trades higher token use for stronger results and faster time to result on difficult work, so reserve it for tasks that justify parallelism. A small isolated edit does not need 4 workstreams. Use parallel agents when the problem naturally decomposes into independent pieces with clear contracts. Even strong coding agents need boundaries around secrets, deployments, destructive commands, and production data. Parallel speed should never remove approval points. 22 passing tests prove the behaviors we specified, not perfection. Keep manual review for accessibility, security assumptions, and production environment differences. The reusable pattern is simple: define contracts, split ownership, isolate worktrees, run branches in parallel, merge deliberately, then verify the integrated system. The download includes SprintPilot source code, tests, agent rules, acceptance criteria, and the exact Codex Ultra prompt used to structure this tutorial. 4 parallel workstreams built one complete application integration, caught a real bug, and the final repository passes every test that is useful coding with agents.